I'll start with hello and welcome to the Underground. My name is Amit Shilo, and I am managing our wonderful community alongside our amazing team of volunteers and supporters. We're honored to welcome you all with us today. Before we will dive in with our amazing guest, I would like to briefly introduce you to our community. So, we are the Web3 Devs Underground, and we are a community of developers and builders founded on open source values by Shauli Rejwan and Roy Yosherov. Since our inception about 4 years ago, we have consistently hosted in person and online events, bringing together some of the brightest technical minds in the space. We're committed to delivering top tier technical content to the global Web3 community, and we're thrilled to have you all with us today. To stay in the loop for future events and updates, please join our main group on Telegram, where all the important stuff is happening. And I encourage you to follow and subscribe to all our platforms. We're active on Luma, Meetup.com, X, YouTube, and LinkedIn. And you can find everything on our website at web3devs.org or in the link tree of the community. And you can also scan the QR code on the top of the screen to take you directly there. A special thanks to our community sponsor, Masterkey VC, an early stage venture capital firm focused on infrastructure and deep tech across the Web3 ecosystem. With a team of 16 world class cryptographers and several technical experts, led by managing partner Shauli Rejwan, Masterkey operates across all major crypto hubs. And now, without further ado, let's kickstart today's deep dive. And I'll start with a short intro about today's session to give you some context. So, some of you were with us on January already, where Gabriel came and told us his story about the 250K bug that they found, one that is an AI agent basically found, which is an amazing story. But a story, as you know, is not a tool. And for 7 months, if you've asked how can you actually do that on your own, the honest answer was you basically can't, because it's their internal stack. So that has changed. And today, Open-Kritt is now public, and even made short banner. So Open-Kritt is now public. The methodology behind those payouts is a repo you can actually clone tonight. So January was the story, but today is the actual machine behind it. This is an architecture talk and not a demo. So why you launch one focused agent per entry point instead of one strong agent over the whole code base, or how to duplicate findings on the same bug that doesn't come back at you 9 times over, why you rank vulnerabilities against each other rather than against a severity rubric, and also what the agents can reliably miss, which is the part we will be pushing in the Q&A part at the end. And you're also welcome to join me there if you prepared your own questions or have anything that you're thinking during this session. Feel free to comment on any of the places that we're broadcasting this to. We'll try to look at it and ask them live with Gabriel. So we're thrilled to be joined by Gabriel, the security researcher and founder at Blockchain, the team behind Kritt. I'll add you to the stage, Gabriel, just a sec. Hey, how are you, man?
Hello. Great to be here. Thanks
Good
for
to
inviting
hear
me.
you. Thanks for coming. So one last thing, Kritt publishes a track record of more than 1.5 million in bug bounties payouts. Am I right, Gabriel?
Yes.
And an all-time high of 18 ranking on Immunify, which is amazing. So Gabriel is the speaker. That's it. I guess the mic is yours, man. I'll be here to ask some questions and bother you during the session, and I'll try to ask only smart questions, but no promises.
Okay. So thank you for having me. I would like to say that today's talk is going to be a bit about why we created Open-Kritt, how does it work, and the philosophy behind it. And thanks Web3 Devs Underground for hosting it and for helping us. The last time I tried to do a webinar, it crashed the Discord stuff, so it did not work very well. The recording came out pretty shitty, so that's already a huge help. So yeah, let's get going. Start by sharing my presentation.
No worries.
Okay, so tell me when you can see my presentation.
Awesome, I can see it.
Great. So this is a presentation that. Oh, sorry. Okay. So yeah, let's talk about Open-Kritt. What is it and how we created it and how it helped us. But first, a little bit about me. I know that we mentioned before. Currently, we are ranked at number 18 all time on Immunify and number 7 all time on Hack'n'Proof with more than 1.5 million bug bounties. I came from a background of mobile and web security, transitioned to Web3 security about 3 years ago, 4 years ago, I don't remember exactly. And now I am in the AI orchestration and AI research community, and this is the main thing that I'm working on. So we built Open-Kritt with a single question in mind to start from: how an AI can help us find more vulnerabilities. And the naive idea would be, let's take the repo and throw a prompt in it. Let's ask it, hey, can you find us some vulnerabilities? But this approach won't work. Everybody who tried it knows it, because repos today are not like CTF, for example. You have huge code bases with more than 100,000 lines of code, and you have a lot of complex machinery that works together. So it's very hard for a single context window, a single prompt, to be able to understand all of it. And additionally, the task of let's find vulnerabilities is a very opaque task. What are you trying to achieve here? What does it mean, vulnerability? Because it's a broad term. You can have a lot of range of different vulnerabilities with different impacts. So all of this was being compounded and accumulating, and a single prompt against a single database code base won't work. So we thought we need to split the task into subtasks. And if you think about it, this is the same way that researchers work. Because if you take a code base that you're researching, you're not going to sit and try generically ask yourself where are the vulnerabilities. You're going to break your task into different substeps. You're going to say, wait, first of all, what is my surface? What can I actually research? What is the area of research that I can access? What is the actual surface? What payloads can I propagate through the system? What inputs do I control? What I don't control? There are a lot of different steps that you, as a researcher, you're already taking subconsciously when you're researching. So why not do the same with AI? Instead of one big, very weird task, you can split it into subtasks, smaller tasks. And now the AI has a better chance of finding vulnerabilities. So if we go to our previous example, you're looking at an entire code base asking to find vulnerabilities, not very practical. But if you ask it about a specific function, are there vulnerabilities in this specific function? You already have a better chance of finding vulnerabilities. And if you ask it even further with a more specific question, is there a buffer overflow in this specific function? Now you have even a better chance of finding that specific issue. So the name of the game is let's create subtasks. So that was the core philosophy when we started Open-Kritt. Just as we talked about before, we're going to split the research workflow into different subtasks and go through each of them. So for example, as we can see here, enumerate endpoints. Let's find all of the endpoints. Let's pair this specific endpoint with a specific impact. For example, a crash, which is across all vulnerabilities you can. Finding a crash, it's a very interesting thing to find. And then you can even trace a specific path, for example. But the idea is taking your research flow and splitting it. So this is the core idea of Open-Kritt. It's not a plug-and-play system. It's more of a tool that you can use to help you with your research process, and that it relies on your creativity, on your ideas, and Open-Kritt provides you the system to control it very easily. Because aside from just the workflow, the single steps of let's find the vulnerabilities, Open-Kritt also includes inside of it another important opinionated system that we had learned through trial and error during our time. In the past few months, when we were working on doing AI research with AI, we found out that there are a lot of other steps that are very important. Because let's say you got the vulnerabilities. Now you need to know which one you should look at first, because usually the models are scanning a lot of codes and finding a lot of things, but not everything is equally important. Not everything is equally interesting. So we have a very opinionated decision in Open-Kritt that we force you to provide rankers. If you don't provide rankers, you can't create scans, and it helps the AI to prioritize what is more important. Additionally, you have the deduplication process, because if we split the task into subtasks, some subtasks can find the same vulnerability from different approaches. And you don't want to look at the same vulnerabilities 10 times, because your time as a researcher is very important, because this is the biggest bottleneck in today's age, in the AI age. Humans. We can't go through everything. We can't go through every line of code. So it's not realistic to go through every vulnerability that the system outputs. So yeah, we have the duplication, we have rankers, and we have postscripts. Postscripts is something that you can customize yourself to do every activity you want on every prompt you want on the resulting vulnerabilities. For example, you can verify them, you can create a POC, you can create a report, you can check if it's been patched, if it's a no vulnerability. There are a lot of different postscripts that you can create. And again, this is something that we kind of force you to provide when you're using Open-Kritt. So it's not just a system for orchestrating the vulnerability part, the vulnerability research part. It's also a system to prioritize the important vulnerabilities and to find you the actual impactful ones. Because when we're talking from bug bounty standpoint, this is what's interesting, right? You're not going to get paid on simple issues that the project will say, oh, it's informational, we don't care about it, and it's not something that's very interesting for us. So I think the value is in looking for stuff that are actually important, and your time is important. So everything in Open-Kritt is built with this philosophy in mind. Okay. A note about Open-Kritt. I don't think this is the only way to do vulnerability research using AI. You might have seen like different talks on the internet or different research papers or different mythological these and and different concepts. But this is simply what works for me, and I thought sharing it with others might help them. So take everything that I'm saying like as a baseline of what works for me. You might find like different ideas and different models that work for you better, or different ways to extend Open-Kritt for your specific use case. This is just what I find that it's very helpful. But keep in mind, this might not be the only way, and stay open to ideas and research. This is something that I encourage everybody who's like doing any sort of research to keep in mind. So it's important to me to say that it's not a monopoly on like what works and what not. There is no right or wrong. In the end, we're judged by the amount of critical vulnerabilities we find, and this is just a method that I find that works very nice. So I hear a lot in the internet and Twitter and stuff like that. People are asking like, why are we not releasing all of our workflows? Because like we released this open source tool, but it comes currently it comes only with example workflows. And those example workflows are actually good workflows. They can find vulnerabilities, but they are not the only workflows that we work with internally. internally, we have a lot of workflows that we created over time, but there's a reason that we're not releasing everything, because if we release, let's, for example, say we have a specific workflow and it's a very good workflow, and now we release it to the public. Now everybody sees this workflow and everybody can run it. So everybody will run it. And then all the vulnerabilities that can be found with that workflow would be found. So only the first one to report them would get the bounty. And then this workflow will be dead. It won't provide any use to anybody else because everybody is running this workflow by default and there is no additional gain to get from this workflow. So Open-Kritt is not a system that is meant to be plug and play system. It's not like you download it and you just run it on your code base and boom, you get vulnerabilities. Because everybody would just do it, and after the first week, there won't be any new vulnerabilities that you can find with that built-in workflow. So what I'm trying to say is that the system is amplifying creativity. You need to create the workflows that work for you, and you won't gain any interesting edge from using open source workflows that we provide because they're common knowledge. Everybody would see them, and it won't be what gives you the edge. So the best thing I can do is help you learn how to create workflows and how to utilize your own strength to create those meaningful workflows. And that is what I'm trying to do with this talk. I hope that we will be able to provide you with ideas and concepts and like a way to look at workflow creation and how to use Open-Kritt, and then take it to your own place and take it to your own ideas and find those unique vulnerabilities that we haven't thought about before. So yeah, that's about it. Now, let's look at the system itself. I'm going to switch my my screen sharing. Give me a second.
Yeah, no worries. And if anyone from the audience thinks he has a good way to use Open-Kritt, or to change it, to fork it, anything like that, just like tell us in the group. Tell Gabriel. We would love to hear it.
Yeah, totally. Like this is open source for a reason, so feel free to contribute and to provide like ideas, because there are already a lot of contributors and a lot of ideas that we implemented from the community. I will show them to you in a second. You all can see my my screen?
Now we can.
Just a second. Whoa. Let's stop it. I think there's...
No worries.
Let's do this.
For now, if anyone is still not in our Telegram group or doesn't know Web3 devs yet, you have the QR on the top of the screen. You can scan it or just ask us to join the group, and we would love to have you there. It's open source and free for everyone, so you're more than welcome.
Okay. Sorry, I had some mess with my tabs, so I'll share it again.
I think this is the...
Okay.
It's kind of a must for builders now. Oh, okay.
Yeah.
Now we can see.
We got it?
Yeah.
Yeah. So I wanted to start with the repo itself. This is Open-Kritt. You can just clone it and start to play with it yourselves. And you can find the repo here. And now I started a fresh installation of Open-Kritt, and we will go over it. We have here some workflow that started running before the talk that I wanted to use as a demo, but it's still not over. It's still running. So sorry about that. I will talk about it later. So let's leave it for now. So yeah, after you install Open-Kritt, you are going to get the following system. As I said before, this is the system for creating workflows and scans. And you have all of the tabs here, the workflow tab here, the PostScript that we talked about before, and the rankers. And also, I didn't talk about it during the PDF presentation because agent skills is not something that we invented or anything new. So like you all know and love agent skills. You can find the skills here. And yeah, that's the system. Additionally, you have like account and settings. I'm not going to open the account for obvious reasons. I don't want you to like see stuff you aren't supposed to see, and settings is settings. So yeah, the way I usually like approaching Open-Kritt is most of our time is meant to go in creating interesting and important workflows. And I think we'll spend like most of our talking about like the workflows themselves, and then we'll have some time to go over severity rankers and postscripts. But this is like the meat and potatoes of Open-Kritt. Initially, we are welcomed with two workflows out of the box, and those workflows are intended as an example, because I think all of your workflows ideas can be split into two main workflow types. There are targeted workflows and there are general workflows. What is the difference? General workflows are workflows that are meant to find like general vulnerabilities. The workflow itself is not looking for anything specific. So it's kind of similar to the first question that we asked. Like we're looking for an impact, not a vulnerability, and we're asking the codebase to find this specific impact. In contrast, targeted workflows are workflows that meant to find a specific issue type. For example, in Cosmos-based blockchains, if you have a panic during the ABCI methods, the entire node will halt. It will crash basically because there is no panic recover during the ABCI methods, and as a result, it can halt the entire chain. So we know the kind of vulnerabilities we're looking for. We have a target. We have a specific vulnerability type we are trying to find, and we created a workflow that is meant to find this specific vulnerability. And the scan that I have here was meant as an example. We have a nice blog post. So credit to US Man Khan. I don't know how to how to say his name. He's a very talented researcher. And there is a very nice blog post that he wrote about an issue he found in Say that was a panic during the ABCI method that allows to halt the entire chain. So this is a very nice blog post. I encourage you to read what he wrote. Additionally, he had another bug here, but it's not in the scope of this talk. And this workflow is based like on the similar idea of this kind of specific target vulnerability that people can look for. Now we automated it with AI. So yeah, this is the two main types of workflow genres, you can say. The general one and the specific one and the targeted one. And yeah, you keep that in mind when you're creating workflows. I think working with targeted workflows is more intuitive because you know that you're looking for something specific. So this is what we're going to use in our example right now.
I have one question, here, Gabriel, before we continue.
Sure.
Is it reasonable for, let's say, people starting in the field to start with a more generalized workflow just to identify the potential problems in their specific use case and then go into specific things with the specified workflow? Or is it not like a B phases and more like just a general thing to run before you start anything? Like, how do you see it?
I think it's best to like run multiple workflows on the single target. So it's not like either this or that. I think it's and. The workflows are serving different goals. So I'll say like targeted workflows have a better chance of finding the specific vulnerabilities you're talking about. But the problem is that no one guarantees that the specific vulnerability that you picture in your head is going to be in the code base. So general workflows are meant to be like a wild card, to find vulnerabilities that you're not necessarily expecting to exist. So, for example, if we look at the external flow workflow, the way this workflow works is by first like mapping all of the external reached entry points. From each entry point, find all of the flows these entry points can reach into the code. And the last step here that we have in the last depth, we have several steps, is for each flow, look for a specific impact. It's not looking for a specific vulnerability. It's not like you're saying it, hey, look for buffer overflows, or look for use after free, or look for overflows vulnerabilities. It just look for a specific workflow in this specific flow. So as we talked about it before, we have a subtask. Instead of looking at the entire code base, we're looking at a specific flow, and we're asking the model to find a specific vulnerability type, like a specific vulnerability impact, not a specific vulnerability, and the model can be creative. So this is like the power of generalistic workflows, but it relies a lot on you can't exactly predict what vulnerabilities you're going to find with general workflows. And if there was like a special magic general workflows that find all the vulnerabilities, it would be like the holy grail. So we still need targeted workflows because, for example, when I'm researching a Cosmos-based repository, blockchain, I know that ABCI methods will cause a chain halt. So I can use that specific knowledge to my advantage to look for this specific type of vulnerability because I know I'm going to find it probably here. Another example, when I'm researching code bases written in C, I know that I can look for memory vulnerabilities. So I'm going to create a targeted workflow to look for example, for dangerous index access for array, or look for some mem copies, like when you copy memory from one address to another, and the size is not necessarily the same size of the target destination buffer and stuff like that. So there are a lot of classes of vulnerabilities that you can expect to find in different code bases and different projects. So you can utilize this to your advantage. So this is the idea with targeted workflows. And now a bit more technical, because Open-Kritt provides you a lot of flexibility with how you create workflows. First of all, we have here this generate with AI feature. I will talk about it later, but for now, let's start with a blank workflow. The way Open-Kritt works is by separating your tasks into different depths and different steps. Okay? So a depth is something that runs concurrently, and each depth runs one after another. So for example, let's write something here or something here. Currently, we have 3 depths and 3 steps. The first steps provides results. Those results are going to then spawn an agent for every result from the previous depth. We're going to spawn an agent with the task from the next depth. And you can have, for example, siblings. So in that case, for every result from depth 0, we're going to spawn 2 agents in depth 1, 1 for each result, 2 for each result. One of those. And this is the way and Open-Kritt allows you to create those schemas of how to process the code base. And you have a lot of important features that Open-Kritt provide you, which are dynamic features. For example, you can embed in your workflows, in your steps, variables, which are piped down from each step to the next step. So, for example, you have the built-in variables. Built-in variables are coming from the scan metadata. When you're starting a scan, you will have the repo you're running on, the commit, the repo scope, dependencies, blah, blah. We'll talk about it later. And you can access vulnerabilities by doing 2 brackets. And then you have all of the vulnerabilities you can. All of the variables you can. I don't know why I'm saying vulnerabilities instead of variables. And then the step needs to also provide an output. And you have here the output format. For example, entry point can be a string. And here you created the output format JSON type. And later you can use those. Right now we created, for example, this key. And in the later step, when we went down a depth, we can access it. You see, we have the previous variable here. And this way we can access data from previous steps in our next steps and provide like a meaningful workflow that builds on the results of the previous steps. Additionally, there are a lot of very important features in how to digest results. For example, a step can either provide multiple outputs or a single output. So for example, this step, map external entry points, it's looking for, we'll look for all of the entry points. So we want to provide multiple outputs, and we can control it here. Multi-output simply controls, does this step provide a single output or a multiple outputs? And for each output, the next steps are going to start a new step. So this is also an important feature. And we have an additional feature, how to handle those outputs. So let's, for example, delete this step because it's a bit confusing. Currently, the first step here creates multiple outputs, and for each outputs, we create a single instance of step 2. But what if we want to run on all of the outputs at once? So we have here this feature, all at once or one at a time. All at once simply means that even if the previous depth provides a lot of outputs, we're going to wait until it finishes, and we're going to consume all of the outputs as a single array. And we can access this array with the special key, multi-output, and then the depth number. So this would be all of the results from the previous step. Now, one last important detail about workflow creation. As you saw, you can, first of all, have variables that you get from the scan. You have variables that you get from previous steps. So for example, this step, var1, var2, and then you can access var1, var2. And also we have one less important variable called the extra variable. Okay, here it is. The extra variables, it's a wild card. It's a reserved extra key followed by a dot, and then you can write everything you want. And this is a dynamic variable that you set when you're creating a scan. We will show this later. So I want you to remember that this exists, because it will make more sense when we're creating the workflow. But this is a very important variable that lets you customize workflows in the ways that we at Kritt, we didn't expect, because there are some built-in variables that we provide for you and that we ask you to manually insert, but like we can't like think of all of the ideas. Like people are going to be creative and think of new ideas. So the extra variable is just for that. When you're creating the scan, oops, I forgot something here. Yes. When you're creating a scan, you will be required to set the extra variable, and we will see it later how it works. And it's meant to help others be creative and dynamic and stuff like that. So yeah, this is very important about workflows and how workflows work. I have another additional feature, which is for the advanced bunch of you guys. And I'll just show it quickly. And if you will have like questions about it, so you can join the Discord community always and like ask me personally and look at the docs. But this feature is very important. I'll show it here. So currently, let's call this step 1 for this example, step 2, step 3, and step 4. Okay, so the way this works right now is that step 1 and step 2 are going to produce multiple results, and then step 3 and step 4 are going to be spawned for each result of both of them. So if step 1 produced 2 results and step 2 produced 2 results, we have in total 4 results. So we're going to spawn 4 agents for step 3 and 4 agents for step 4. That's 8 agents. And you might not necessarily want to consume all of the results of step 2 in step 3 or vice versa. So you have an important feature called binding. Binding allows you to bind the results of some step to the input of the different step. So now we can see that the results of step 1 are going to be outputted as the input of step 3 only. And this is not going to reach step 4 and vice versa. So this is a very important feature. You can keep in mind that it exists. And this way we're allowing like a level of freedom when working with workflows. So that's about workflows. Now let's continue. You, for example, created your dream workflow. Now
Gabriel,
you have
is it good time to stop for a question from the audience?
Yes. Let's go for it.
So I'll bring it to the stage so we can read it. Just a sec. Okay. So Mario is asking, in the Cosmos workflow, you defined 4 methods for identifying panic vulnerabilities, explicit panic calls, arithmetic panics, nil pointer, and bounds, and type-related panics. So what if I know which specific bug I'm looking for, but I don't know all the possible ways to detect it?
So you can make it more general. So for example, if I did not, so for the Cosmos Panic example, the way that I went about to create this example is Cosmos-based blockchains are written in Go. So there is an infinite, like there's specific ways that Go will result in throwing a panic. So you can just search the internet like, hey, what ways are going to result in panic in Go, and create like variables, create like siblings for that. Or alternatively, let's say that I don't know which panic options are there in Go. I can just make the workflow more generic. Like we talked before that the workflow can be either generics or targeted. It's not entirely true. You can make them a bit of both. So we know that we're looking for workflows that results in panics in ABCI methods. So we can split it by first looking for ABCI methods. And then instead of like saying it, hey, look for explicit panics, we can look for panics in general and ask the model to maybe search the internet or use its knowledge from before to search for the panic. So for example, in this prompt, determine whether an attacker can reach an explicit panic path. We can change this to can reach any path that will result in any type of panic. And then we can, for example, include like more information for the model. Like we can say, I'm not an expert in what makes programs panic, so feel free to search the internet and use your knowledge of Go to determine can cause a panic. So yeah, for example, you can always like change your workflows a bit, but in this case, the trade-off is that I talked about it before. I think like the best way to utilize AI in research is to give it smaller, more well-defined tasks. Like the better your task is defined, the smaller it is, the results would be better. Because the bigger the task, the model can like start to lose context, and it will have like too much on its mind, so it might miss it. This method can still work, but now the task that we're giving the model is a bigger task. So the percentage, like the statistical percentage that it will perform well, is lower than before. It would be harder for the model to find all of the panics. So it's a trade-off. But if you don't know something, like if something that you're not an expert at, you can always like think of, can I make it somewhat general, or other way around, you can research it yourself, like using Google or using like other tools, or you can even maybe provide here an additional step before. You can create here, for example, a step that says, I don't know, find all ways that a panic may occur in Go. And now we have like a step before our next step. And here we can provide a multiple output of like panic type, panic explanation. And for example, if we send the model with a prompt like this, it may come back with like, oh, there are 4 main ways that a panic can occur in Go. There's like the arithmetic panics, explicit panics, and blah, 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 blah. And for each of those panic methods, we can use them here like dynamically. Determine whether attacker can reach the following panic type. And then we can provide the panic type explanation. If I'm not writing explanation right, forgive me. I'm not the best at writing like long words. I think this is the right pronunciation. So yeah, you can always use like a step before, like provide an additional step to make the task like more well defined. Your goal should be, how do I split the task, like the task that I'm thinking of, finding panics in Cosmos-based blockchains, into smaller subtasks and more well-defined missions. The smaller the context and the more well-defined the mission is, the more likely is the workflow to find the actual vulnerability. The other problem with that is obviously like how much tokens you're going to spend. So it's a question that you should like ask yourself and work with it yourself, like trying to optimize your workflow, because ideally we would like the model to like look at every line of the code, but it's not realistic. It is realistic, but it won't provide much value unless you like burn a lot of tokens. So you need to find like the middle ground of how to split your task into subtasks and what tasks we want to make smaller and stuff like that. So if I understood the questions correctly, which I hope I did, in case that I would not know like the various different ways that a panic can occur in Go, I would either like add another step to provide this information for me. And obviously like make the prompt better and like improve it, blah, blah, blah. But like, yeah, this is like the general way that I would approach a task like that.
Awesome. Thank you, Gabriel. I hope, Mario, Gabriel answered your question. He has another follow-up question, but let me know if you want to take it now or later.
Yeah, if it's related, so let's run with
Let's see it. So, do you use fuzzing or formal verification in your methodology? Have you tried integrating stateful fuzzing or formal verification into Open-Kritt?
So personally, in Open-Kritt, we did not try to integrate fuzzing or formal verification. I saw on Twitter that there are some people who indeed did that they're integrated like formal verification with Open-Kritt, and they had some interesting results. Personally, I'm a big fan of fuzzing, but like we have internally, Open-Kritt is like, it's not the full tool that we are using internally, because we're still working on like taking everything that we did internally and like moving it to Open-Kritt, because as you can probably see, like Open-Kritt is a nicer looking project and like more well-defined and more generalistic. And our internal tool is like a hell show. it's very weird and very specific to how I use it, and like it's not very nice to use. But we're still working on adding other tools that we use internally. So yeah, we sometimes use fuzzing, but we used it more like a couple of months before, like when we started working with AI security. And I think the reason for that is that we feel that models are starting to get a lot smarter. So you have like a lot of more value of using the models to do static analysis and fuzzing like everybody can do. So we're trying to look for an edge that works for us. And I don't think that for me an edge would be like fuzzing, because everybody is doing fuzzing and everybody is doing fuzzing pretty well. So currently it's not a big focus, but it's something that we did in the past.
And just questions for dummies like me in the audience. Can you explain shortly what does fuzzing means?
Yes. So fuzzing, let's say you have some function that's supposed to do, I don't know, something. Fuzzing is just trying all of the inputs, like brute forcing them very fast. But fuzzing also does it like smartly. It is the way fuzzing works is like by adding instrumental points to the code base before it like compiles it and stuff like that. So it can know for each input what branches of the code it actually reached. So fuzzing is not like trying every input brute force way, like stupidly. It's also trying to understand like, have I reached new branches of the code, and what inputs are getting into different positions, and like trying a lot of different inputs very in a smart approach, and trying to reach like interesting locations. For example, some paths that you should not reach, or like crashing the program, stuff like that. But in the basic idea, it's like a method to brute force a lot of inputs on the specific like harness that you create, and trying to get some interesting results, while fuzzing is doing it in a very smart way. It's very complicated, and I think it's like very cool how the coverage works and how fuzzing chooses what inputs to try next and like stuff like that. But I think like the most interesting part that LLMs can provide us is like very interesting static analysis, and fuzzing is a tool that is used in different scenarios. And yeah, I hope like this is a very short explanation of what fuzzing is.
Now, at least for me, it helps. Some people in the audience also asked if fuzzing is an agent skill at the moment, or is it built in another way? I'm not sure.
So,
Can you answer that?
yeah, so the way that in general in Open-Kritt, how it works is that all of the agents are running like in a container that they have like full permissions on the container to do whatever they want. So when we want to use fuzzing in an agent, we just provide it with the necessary tool and access to the CLI and like to the entire container to do whatever it wants. So it like writes fuzzing for itself. You can use it as agent skills, like you can create agent skills for fuzzing. I don't think we have skills here for fuzzing. Maybe we don't have, I don't know. Fuzzing. Yeah, we have some skills here related to fuzzing. So you can always like use it.
Amazing. Thank you, Gabriel.
And yeah, but
I'll
yeah,
keep the rest
in
of the
general.
I'll keep the rest of the questions for later, so we can continue.
Yeah, but this is like a good note. Like in general, every agent in Open-Kritt runs in a container that it has like root access on it. So you can, in your workflows, you can tell an agent to install tools and run whatever it wants. So for example, you can say install, I don't know, Jidra and reverse this binary, blah, blah, blah. But it has like access to do whatever it wants. So if you have like ideas that we did not think about, so feel free to like give the agent to do whatever it wants. that's very cool. And I think like this is an important note to say. So thanks to whoever brought it up. Yeah, let's keep going with the Open-Kritt tutorial, we can say. An important note that I forgotten to say before, another opinionated part of Open-Kritt is that the last step of Open-Kritt must have the following keys. As you can see, like if we delete one of the keys, the Open-Kritt system won't let us save the workflow because the last depth must always have those keys. And why is that? Is simply an opinionated part that we force you guys to use because we think those keys are important parts of what you need to investigate your issues. The explanation, the file path, the line, the malicious input example, a summary, trigger flow, vulnerability ties, and the malicious actor. Those are like the minimum keys that you should use. You can also like always add your own keys, but we force every workflow to end with those. And now you might ask yourself, wait, but where do I put the step that verifies the vulnerability? Because now we only created like workflows to find vulnerabilities. We talked about it before. Where are the rankers? Where are the verifiers? And this is like where it comes here, the severity rankers and the postscripts. The severity rankers are just a set of rules of how to rank the vulnerabilities in relation to each other and in relation to the critical, high, medium, or low like impact. So how it works is fairly simple. You just create ranking rules. Like for example, if the vulnerability requires I don't know how to write privilege. I think it's fine. Privilege access, then it should be low or something like that. Just you can write in free text all of the ranking rules that you can think of that like important to you. You can use the ranking rules of the program itself. A lot of bug bounty programs have like ranking rules that they are using, and this is a very important feature to help you like use your time better, because not everything is going to be as important as other stuff. So make sure you're not skipping on the severity rankers. We have like an example ranker here, for example, what makes critical issue, what makes a high issue, stuff like that. And now for the other part that we talked about, postscripts. Postscripts is a lot of like very similar to workflows, but like a single step of workflow that you can run on the findings themselves. And this is the distinction of where I verify my reports. So, for example, we have some built-in workflows, built-in postscripts. For example, the resource exhaustion. This is a postscript that we created because when you're looking, for example, for a chain hold vulnerabilities, you can have the model can say, yeah, you can send like 1 million requests to the node and it will hold because it's processing a lot of requests. But like a lot of projects are going to be like, yeah, we don't care about it because like it's not very realistic and we have like throttling in the network level or stuff like that. So we have this postscript that simply takes the vulnerability as an input and checks if this vulnerability is a resource exhaustion vulnerability or like a different vulnerability that requires something else. Because like resource exhaustion, a lot of projects will also say like, yeah, you don't know how much resources the validator actually has. It's not a reliable chain hold or stuff like that. So it's just something that we experienced a lot. And you can use those postscripts to take the vulnerability as an input and create some interesting output. So for example, how easy is it to exploit the vulnerability? This, for me specifically, it's a very important postscript because I usually prefer to look firstly on vulnerabilities that are very easy to exploit. They have a better chance of being criticals. Because if the vulnerability is like requires very rare condition, the team can say, oh no, it's like not very likely. So you can use those to create your verification process. For example, we have here the POC creator. This can also be used to verify if the vulnerability even works. Currently, we use this to create the POC, but you can say like, hey, is the vulnerability even valid? Create a POC, check it, and if it's not valid, return for me that like it's not valid. Valid? Question mark? We don't have question. And like, so this is the idea of postscripts. And those are very important. Do not skip those. And like, this is your chance to add, to enrich the vulnerabilities and to verify them and to create like POCs and stuff like that. And now let's finally talk about creating a scan. So when we create a scan, we simply choose the workflow that we want to run on. We can choose between local and remote targets. Local targets are going to be in your local repo. When you're cloning the repository, the Open-Kritt repository, you can see that we have a folder, local repos. Currently, it's empty, but you can add here like repositories that you can clone, and you will see them here when you're pressing the local. I don't have any because it's like a clean install. Remote, it's like a simple GitHub or GitLab repository with a specific commit. You can leave it blank for the head commit. Scope, not all of the time you will want to run on the entire code base. For example, sometimes you would like to check only a specific component. So you can use the repo scope for that. And dependencies, I think it's also an important field that you can use, because sometimes you want to give extra attention to specific dependencies that your code base is using. Like intuitively, the model can check, like, for example, the package JSON of the project or like the Go mod file and see like the dependencies, but you can also specify them directly. And this can help you like control which dependencies should receive like more attention, which less. Now I think this is one of the most important fields, the configuration. A lot of code bases, like in general, they have different configurations that control like which feature flags are open and which are not, and which parts of the code base actually works. This is very important because in bug bounties, if you find a vulnerability that is not currently exploitable on the current configuration, you're going to get like closed and say that it's invalid. So always make sure that you check what is the current configuration of the code base and that you write the correct configuration here, because it will help your model a lot. And before, we talked about the extra variable. When we're creating a workflow, we can provide like fields to the extra variable. Here you can see them. All the fields that you create. So for example, currently we have only this field, but like if we will go back to the workflows, let's create quickly a simple workflow that uses extra and like put all the fields. Now we have this stupid workflow. And when we choose this workflow, you will see that now you are forced to put a value inside the extra field because you used it. Now, all of the values that you are putting when you're creating a scan, those are the built-in variables. We talked about it in the workflow. Like we said, you have the built-in variables, right? When you open the prompt that you're writing, you have here repo full, commit SHA, repo scope, dependencies configuration. We just now saw where you can fill them. Those variables you receive from the scan itself. The configuration field is going to appear here. So when you're creating a scan and you're like providing configuration details, but if you never use the configuration variable, your workflow won't be aware of this variable. It's not like we're injecting it into every prompt. So make sure you're using those variables. And that's why you will notice that our first, when you create a blank workflow, on default, we add like an example with several variables. You see? this is meant for you guys to know that like those built-in variables exist and that you should use them. So yeah, let's go back to creating a scan. Okay, let's go back to creating a scan. When we create a scan, after we fill all of the previous values, we can choose the model that we're running at. And we talked about before, like we have some community features. We can customize the depth that we're using with the different models. You have a different model for a different depth. This was a community idea. A user from the community said maybe we can have like different models from different steps. We created it with them. And here we have like the ability to control the post-processing model. This is something that we also got from the community and that one of you guys added with the PR for the code base. So again, thanks like very much for everybody's contributing to Open-Kritt. It helps a lot, and we integrate the features that you suggest to us. So keep going on it. By default, you can use like the same model for all of the steps. It is the most simple option instead of like doing all of it manually, but it's a feature that exists. You can choose the skills that would be accessible to the agent, and eventually you can choose like the postscripts. Like we talked about before, POC creator, ease of exploitability. Here you can choose your ranker, and you can also add like a specific ranking rules for this specific scan. For example, this project treats criticals as everything that blah, 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 blah. And you can add here like additional rules, and you will see like the combined rule sets, how it looks in the end. It's just concatenates like everything. So yeah, this is the main features of Open-Kritt. Oh, cool. And we have I thought that it won't finish yet, but it's pretty cool to see that we have like already some results. This is, as I said, like a workflow and scan that I created to demonstrate like how it may look. And we can see like we have a lot of results. The results are not rated yet, so a lot of results can be like not very interesting and not very important. As you can see, yeah, we can see like by the malicious actor, that the malicious actor is not something very interesting, but as you can see, the workflow is still running, and there are a lot of other ideas that the workflow need to go through. So I'm sorry that it's not finished yet. I wanted to show like additional features here, but yeah, in general, this is how it would look. And yeah, this is Open-Kritt in how it works in general. And I want to talk about like one last feature that I think is like very helpful for workflows and for post-scripts. We have like the generate with AI feature. Generate with AI feature allows you to generate workflows in a more simple way. Instead of like sitting here and writing the entire workflow from zero, you can explain to the AI how you wish your workflow would look, how you wish your workflow would work, and the AI would just create an initial structure of the workflow. But this feature is also very dangerous. Why? Because the AI is not necessarily creating very good workflows. It's an AI and it doesn't necessarily know what is the best workflow to create and what is the best way. I think the best way to create workflows is, again, with your own unique ideas and your own unique methods. So don't rely on the generate workflow with AI too much. It can look like it works. It can look like it's creating like meaningful workflows, but use it only to create the initial structure of the workflow, and then modify it by hand. Start like changing the results and stuff like that. I have here an example that I created in advance. I will show it and then we'll talk about it more. So for example, this is how we can use the generate workflow with AI. We're saying like, I want a workflow for discovering chain halt via explicit panic calls. So we're looking for every place that there's an explicit call, a panic call, and we want to find all of them and create a workflow for that. So the way we thought about going it is like, first, find all explicit panic calls. That would be like the first step. Then for each panic location, determine if the panic is actually a crash or not, or is it recoverable. Because, for example, you can have catch and wind or recover or try catch, depending on the language. And if the panic is recoverable, it might be able to hold the chain if it creates like a zombie node. So we define like the core ideas, and we write like how we wish the workflow would look. And then we can, let's create it with a simple model so it would happen fast. We can like send the model to create this specific workflow, and it would create the general structure of the workflow. This specific workflow is based on the real workflow that we used to find the vulnerability that we have here. This vulnerability, we got paid $25,000 for it, with a complete chain halt in Cosmos SDK, in Comet BFT, which is run by Cosmos. And this is the general structure of the workflow we used behind it. So I wanted to take like a real world example, like also a simple example that we can relate with very easily. So I chose like a chain halt because everybody can understand what a chain halt is, and we don't need to go like over a lot of like difficult concepts. And yeah, now we created the AI generated draft. But as you can see here, it notes that each AI generated reviews the steps and make sure everything looks and makes sense. So it creates the general idea, but we want to go over the results and make them like better looking, better sounding, and make sure that they fit how we wish to use this workflow. So yeah, this is a very very strong feature, but it's not bulletproof and it's not like the best feature. It is, I think it's good, but it's good for creating structures. You still need to verify the workflow, but just know that it does exist, and it's like a very nice way to create workflows very fast. So yeah.
First of all, amazing, Gabriel. I have one question as a beginner, let's say, with no experience in security. So, do you think I or someone that is, let's say, semi-technical or doesn't understand enough security can use this AI feature, let's say, to do like a full or basic run to check any product they're building? Let's say I'm building something with Claude and I want to see that I don't have any big vulnerabilities in what I've built, and they don't have a security expert ready to check everything. Is this a good use case for this feature as well, or is it an overkill and they should do something simpler?
I think it might work. I think if you're a smart individual in general, you don't need to be like a security expert necessarily. If you're just like trying to secure your own specific app, it can bring you like a lot of value. But I think like the most value to be made with Open-Kritt is by like working hard on creating like very complex and very interesting workflows. And the more invested you're in it, you get better results. But yeah, you can totally like use it to help you secure the work that you're doing. And like you have like already you have the workflows that we created defaultly in the project, and one of them is like a general workflow, so you can always use it like generally on your project and like see if it finds interesting stuff, because the general workflow works. It's like a good workflow in general, and it finds like interesting vulnerabilities, but it's also like a pretty naive workflow. I think like a lot of people already figure out that this is a good method to work with. So it finds a lot of stuff that other people will find as well. But if you're using it like internally, it's a very good baseline to start with.
Okay, so summing this up, what you're saying is basically it's an amazing tool for security researchers and anyone who wants to get the most out of the security, but it's also relevant for people just starting or want to secure their own app or anything like that. It's also a great tool for that. So I hope this is
Yeah,
helpful for our community as well. Is this a
yeah,
good time to ask some questions from home, or
yeah.
do you want
Just I have some final closing words,
amazing?
uh,
Go for it.
which is I think if there's like something you can take with you from this talk is that first of all, like ask smaller questions, like subtasks is a key to working well with AI. It's not something that we invented. You can also see like a lot of people others saying it, and try to like decompose your task into different subtasks. And I think like the other most important thing that I can say is don't rely like on the built-in stuff and use your creativity. Open-Kritt is a tool that rewards like creativity a lot, and it's a tool to allow you to be creative and think like of different ways to use it. It's not a built-in plug and play tool. Don't expect it to be a built-in plug and play vulnerabilities machine finding. So keep trying to like learn the tool and use it better, and be creative with it. Like use it in interesting ways and think about how you approach security research and like what is your personal edge and what you're personally good at doing, and you will get the most reward and most like a return on investment, you can say, if you think like that. So this is like the message that I'm trying to leave you all with. Just be creative, and it's a tool to enhance your creativity. And I'm saying it like a lot of times over and over because it's a very important message. There is no magic plug and play tool that will give you like the next $1 million bounty. You still need to work and you still need to enhance it. Open-Kritt can only help you do it easier, but it's not magic. So yeah, this is the final note that I can leave you with, and that's it from my part with the talk. Let's start with questions.
Awesome. So thank you so much, Gabriel. This was great. Let's start with the questions from home, and then I'll go into the questions from our team. So let's continue with the next one with Mario. Sorry for making you wait. So, do you think cyber trust block degrades the quality of Open-Kritt analysis? Do you think that encountering a cyber trust block means you're probably on the right track to finding a vulnerability?
Yeah, so I think like clearly the cyber block is like not great for anybody, and especially like when using Open-Kritt. But it like forces you to use like different, probably like weaker models. But I think like as you said, when you encounter a cyber trust block, and that generally can be like a good indication that the model probably saw something that like it doesn't want to do. So maybe it's a good place to keep probing. But yeah, I don't like the cyber trust blocks. It's very annoying. But I believe you can like apply to the cyber programs of both Anthropic and the OpenAI and hope that they will accept you. And yeah, this is indeed the problem. I agree. Open source models for the win. Possible to jailbreak it. I'm not going to encourage jailbreaking. So,
Okay, great. How do we tell the agent what's in scope versus what isn't before starting the scan?
so first of all, you have like the repo scope parameter when creating a scan. All the parameters that you fill before creating the scan are going to be accessible for the model, Reposcope is one of them. And if reposcope is not enough for you, you can always use the extra variable. You can use like extra dot scope and like write your own information about what is in scope and what is outside of scope, and just in your workflow use it in all of the relevant steps.
Okay, next one. How do you go about picking a model for each stage? Do you trust the existing security benchmarks for AI like CyberGym?
We have internal benchmarks. Like Harel, the partner that I'm working with, he's a great AI guy, and a lot of the stuff that he did like involved like benchmarks that we created internally based on like past vulnerabilities that I found, that the model found, and like known vulnerabilities. And we have a very complex benchmark. Like we can have like another hour talking only about how we're benchmarking stuff. But yeah, we have our own benchmark. I
Awesome.
don't trust CyberGym.
Is it public, by the way, or is it only
Our
internal?
benchmark? No,
Yeah.
it's internal, and I don't think we're planning on
We'll
making it public
respect that.
anytime soon.
No worries. Next one. How do you find the current config for a protocol?
For I think like for in Web3 security, it's like very simple. Like none of the protocols are trying to hide it. You can just find it online and like query the nodes of the protocol, like and see what configuration is currently used in mainnet. Or if you're talking about the smart contract project, you can also see like the configuration used there. You can like read the storage. So in Web3 security, it's very easy to know what the configuration is because everything is like public knowledge and everything is open source to a degree, so it's simple. In traditional security, it's harder, so you need to like probe it. You have like different methods to probe like what is the configuration and what actually is used, or maybe you need to reverse some stuff. So it's different. But in Web3, it's very simple.
Okay. Have you calculated how much it costs on average to launch a medium-sized workflow?
I don't know what a medium-sized workflow. I think like the definition for it can vary. I think in average it depends like on the model provider you use and like the limits you're facing and what thinking effort and stuff like that. So you can launch the same workflow, but with GPT 5.6 Sol on Ultra, or with I don't know, like GPT 5.4 on medium thinking, and it would cost like I think like more than 100 times more. So it's very agent and thinking dependent. We have like internal calculations on based on like the models that we use and workflow that we use. It doesn't cost like too much. Like the cost is very effective. I think I talked about it like on Twitter once for the Fire and Dancer contest that we did. And I think in the contest itself, we ran a lot of workflows, and it cost us something between $2,000 or $3,000 dollars in total. And yeah, this is like depends on a lot of factors. Sorry, I don't have a better answer.
No, it's okay. So the range can be from, I guess, hundreds to thousands of dollars usually,
No,
depending on how
not for a
much.
single workflow. Not for a single workflow. Like the example that I gave, that we spent like between 2 and 3 thousand. We ran like a lot of workflows. Like I don't know how much, but like less than 100, but a lot more than than 10. I think like 20, 30, maybe something like that workflows.
Okay, so we have some kind of range at least. By the way, a follow-up question on that. Am I like, can I connect any LLM I want to this to Open-Kritt, or is it only like API specific for OpenAI models? Like how is it at the moment?
It's OpenAI, Anthropic, and Open Router. You can
Hmm,
create those three providers, and we're working on adding like more providers. Like we did a poll on Discord asking like what provider people would like us to add next, and it seems like DeepSeek is the one that won the contest. So DeepSeek is the next on our list.
amazing. But basically, if I want to connect it today with OpenRouter, I can choose any open source model I want or any model through that, and can basically run it like that, right?
Yes, and you can also like send us a message and say like, "Hey, I want a new provider, so Gabriel, get working," or you can fork it yourself and like add providers. So, and if you're forking it yourself and adding providers, make sure to like create a PR that we will add it to the project. Uh, Another note about it, I saw that we have a lot of PRs and a lot of issues. Apparently maintaining an open source is a lot of work. So don't worry, we're seeing everything you guys are opening and we'll get to everything and we'll add like, not everything, but we will add like everything that we deem is interesting and helpful. So thanks again and like keep doing it. It's like very helpful and I truly appreciate it. And we're seeing everything you guys are creating. Yeah.
Amazing. Next one. The Open-Kritt tool is already powerful, depending on the workflow you want to see. And it was not a
Not
question.
really a
Sorry.
question, but a
Yeah,
statement. Yeah, I agree.
yeah. A nice statement, though.
Yes,
um,
I agree with you.
do you plan on integrating DeepSeek anytime soon? So yes, you just got your answer.
Yep.
Um, and is there a way cheap so you could use much deeper thinking? Okay, the way
Uh,
cheaper.
uh,
Okay, that's a statement as well, I guess. So
no,
I,
I
I
think
think
it's a
this
question.
is it.
They're way cheaper. Okay. It's talking about DeepSeek, I think. Okay.
Awesome. And last question for now. Um, how do you check the code coverage by the scan afterwards?
Uh, that's actually an interesting question. I haven't talked about it, but we have like a feature for advanced users, the executor view, which you can open in when you're running Open-Kritt. It would run at port 8090, and you can see there a lot of like metadata about the run. And in general, I'm going to be honest, like we're not proper, like you can say, our approach is very bug bounty oriented, and code coverage is not as important for us as finding the most impactful vulnerability. So we don't have like a very strong tooling, a very strong UI elements to view how much of the code coverage we actually reached. So it's not something that we're focusing on. But the way that you can do it is by either analyzing the like the prompts and the answers themselves, like using the execution view, or just adding something yourself to the project. But it's not something that we are focusing on. Yeah.
Okay. So I think we can start with our questions, unless you want to show us if the run that you started finished some things that you would like to share. But yeah,
No,
let me
it
know
still
if you
has
finished.
like 100 more
Oh no,
lineages
we'll
to
have to do
finish.
another event. That sounds very nice. Okay, it's a good reason for us to do another one. So I'll keep that in mind. Um, but if you don't mind, I'll start with my questions. I'll lead with the
Yeah, sure.
architecture ones, and then we can jump to the rest. So just give me a sec. I'll bring it in front of me. Okay, why one focused agent per entry point and per bug pattern instead of one strong agent with the whole code base in the context? What broke when you try the obvious thing first? I think you already touched this, but if you want to expand
Yes.
on this point, feel free
Yeah.
to.
Yeah, I think like as I mentioned before, like the context is too big, the question is too vague. the model would just not perform very well because like it would get distracted and it would I think like a problem with a big task, and the big reason why we suggest subtasks is that the models tend to give up very fast when they're doing like a big task. They're searching a specific flow and then they're like, I don't see anything interesting here, I'm going to check another flow. But if you give the model like only a specific flow in the question, it will give up less easily. Like it would try a bit harder and the context would be more clear to the model. When it like does context compression or stuff like that, it won't lose the entire thing that it was researching. It would be like more focused in a smaller task and it just performs a lot better. So yeah, we just that the answer.
Awesome. Next one is relative ranking is the interesting design call. Why is comparing findings against each other better than scoring each one against a severity rubric? So where does it fail, or why this is the choice?
This is simply a choice of like a bug bounty philosophy, because like I want to report, I want to know what is like the worst impact and like what is the best bug that I can report, and like prioritize looking at those. Because as anybody who used Open-Kritt can probably tell, if you're running it on a lot of repos and a lot of projects, you will have like a lot of issues to view. And as I said, like in the beginning, the human is the bottleneck, because after all, I'm not going to like trust an AI to report vulnerabilities to bug bounty programs, because I don't agree with that, like personally, because I don't know what the AI reports, and I made it like a very big part of how I work to not report like slop and stuff like that. So I make sure to go over each vulnerability myself after it finds it. So I want to make sure my time is used as best as it can, because my time is finite and like it's very precious to me. So the rankers is a philosophy thing that we added, like assuming your time is important and you want to prioritize looking at the most impactful vulnerabilities first. And yeah, this is like the motivation behind.
Awesome. Next question. Repeat loops exists because the models are not deterministic, I guess. So how many repeats before you hit diminishing returns, or and what does the cost per scan in practice, like how much is it affected by that? Is it something that you're able to change through the UI at the moment? If you can expand
Yeah,
on that.
so the repeating loops is a very important feature, because it's exactly as you said, the models are not deterministic. So each run you can have like you can run the same workflow with the same model on the same code base, and one time you can find a critical vulnerability and the other it can miss it. So there's a lot of value on running the same workflow again several times. And like smart loops are also important, when you can like say, hey, those are the vulnerabilities that I found before, now expand on those, like to make the model not spend time on the same vulnerabilities. So like looping is an important approach of vulnerability researchers with models in general. And I think like it's a risk, because you can spend like a lot of tokens on looping and it won't help at all, and like but it's worth the one time that it would help. In general, every time that we find like rare vulnerabilities, we're trying to improve our workflows to make sure that that it won't be found like one only once in 10 loops, like it would be found like, I don't know, 70%, 80%, and stuff like that of the times. So looping is very important.
Amazing. Okay, next one. Agents run as root in disposable job containers. Talk about that threat model honestly. You're giving a model tool access with full privileges inside the container against untrusted code. So, yeah, if you can comment on that.
Yeah, so it's running inside the container. So as you said, like it's untrusted code. So if the code is, I don't know, it's weird or does something like problematic, it would be contained to that specific code base. Also, it's like on the users to make sure that they're running on trusted repositories that and trusted project that they can verify that are not doing anything malicious. And so there is some risk for that, but we're trying to mitigate it. Like the agent won't be able to break out of the container and do like malicious stuff on your computer or like install stuff on your computer, but it is like might be exposed to your tokens that it uses and stuff like the API keys and stuff. But again, just like there
Okay,
is
go ahead.
risks. No, I agree there are some risks, but I think they outweigh like the cons. Like make sure you're running on projects that you can verify that are proper, and the upside is that it won't cause any harm to your machine. And the another upside is in the worst case scenario, the model somehow breaks the sandbox and commits some felony, and you can join the felony bench and like say, oh no, we hacked Hugging Face, so we're very cool. And
Yeah, maybe it's even a pro.
yeah, you
Yeah.
can market it like my agent is so good that it hacked. So yeah,
Well,
it's a question of how you look at it. So yeah.
I understand. How do you protect yourself at the moment against something like that?
We're only running on like code bases that we know are like valid because we're running on like big bounties. So you know the project is authentic and it's not problematic. And again, as we said, like it's a containerized environment and it is closed, so most of the risks are mitigated. The main risk that I feel having like a model run openly is like it may install weird stuff on your computer or like delete stuff and delete files and stuff like that. So we mitigate the risk to your own machine, and as long as like you're running on stuff that you can trust that won't have like some prompt injections or stuff like that in there, you should be fine. So I think we mitigate as much risk as we can. And in general, if you guys have like some cool ideas of how to mitigate risks even further, you can always like write for us and like edit.
It might be a stupid question, but can I run this on a VM maybe, or like to not risk my computer if I want?
Yeah. I think like this part is managed by containers. Like it's pretty similar. You can first of all you can run it on VM. You can use like a create headless. It's a feature we created, and also the reason that it runs in containers is to not risk your computer. Because if the agent like installs weird stuff on the container or like deletes everything in the container, like does RMRF for like everything, it won't affect your computer. It would only affect the container. I think like again, like the main risk is that the agent uses your API keys, so it might I don't know, leak them somehow or stuff like that. So a risk for your computer, there is practically like none unless the agent finds a way to escape the container, which is not
Okay.
very likely.
Okay. Next one is the last of the architecture questions. What do the agents reliably miss? Which vulnerability cases are still human only, or what did you have to stop doing because it didn't work, if there are any?
Well, I think the answer for that question is contains a lot of secret information.
Fair enough. So I'll make it more general to see if it's something you would like to answer more. So, what do you think in the long term is gonna stay in the realm of humans to find invulnerabilities, and what can be replaced in a year or let's say 3 years completely by AI agents?
In 3 years, I'm going to work at McDonald's. I don't know. I the way that I honestly, I don't think that I'm qualified enough to like predict what is going to stay in the realms of humans and what machines could do. Like a year ago, I was very skeptical that we will reach the level of complexity that we are at today. So, like intuitively, I want to say that like no, the very complex vulnerabilities are going to still be like like foundable only by humans, but I have no idea. Like AI is evolving very fast and very crazily, so I don't think I am neither qualified nor smart enough to know how it's going to be in the future.
Makes sense. It's okay. So last few questions. Just a sec. Okay, well, this one you already answered. Okay, 2 people, 9 months, and 20 plus high or criticals. How much of that is the tooling, and how much of that is you just doing on your own?
I'm not doing on my own like anything for a while already. So like uh, everything is running automatically, and I'm only like verifying results. And as I said, I'm like writing workflows. Like my job is basically defining like how research looks, and like with the help of Array, like improving it to ways that the model can optimize it, and like making it as best of the workflow as we can, like researching it and benchmarking and stuff like that. But I don't think I did like manual research in a while now. I don't remember already how to read code. No, I'm joking. I still remember how to read code, but like I did not do it for a while.
Awesome. Okay. I wanted to ask about. I know you're also selling services, and you're helping projects to do scans yourself. If you can say it like explicitly, what is the like now you open source this project. I know it's not everything that you can do, but what is the most relevant things people should reach out to you specifically to get your help and not try to face their own?
So to get my help, like ask me anything. Like feel free to write for me anytime. But like the main service that we offer, like paid service, is using our own workflows to scan like repositories or like projects before they go, for example, to mainnet. Like if you have like a new feature and you don't want to go to publish to mainnet, and like before making sure like everything is in order and everything works well, so we can offer to run our tools internally and provide you like with a report with all of the vulnerabilities we found. And I think like it's a good solution to a lot of projects that don't want to pay the the max bounty when it reaches mainnet and like pay a fixed price before. Uh, but we're fine either way. Like go to mainnet without running Open-Kritt, and we'll just find the bounty instead. So or someone else would find the bounty with Open-Kritt and like tag us and write that they found it with Open-Kritt. That also fine with us.
Awesome. I have a question about the harnesses. I know many people here use Codex as the harness or Cloud Code as the harness. What does the harness change that the model doesn't? If you can expand on that a little bit.
Yeah, so the harness provides like tools for the model to interact with the world, you can say. Like it has internal tools to use and tool calls. I think the most important part is a model usually performs better with the harness that it was trained with. So, for example, OpenAI models will perform best with the Codex harness, and like Anthropic models will perform best with the Claude harness. And another example is that the Grok model, the XAI model, if I'm not mistaken, they trained it with the Cursor harness. So
Yeah.
we currently don't support like the Cursor harness built in, but I assume that Grok would probably perform better with the Corsair harness. So there is a lot of the harnesses are similar in some stuff, but they have like different tools after all and different ways to approach the same problem. And usually the way that the model knows better would result in the model performing better. So uh, try different harnesses and see like what if you're using like open router, try both harnesses and like see what works best and stuff like that. Because I don't know like in advance which model would work better with which harness. But yeah.
Great, that's a good answer. Another question on the models. So, as you know, every few weeks or months we get new models coming out, um, and I guess this kind of research resets your tuning. So, how do you build a workflow library that can survive each generation that updates? And is this something that is currently available?
Yeah, so I think some workflows we just threw to the garbage because like models made them like obsolete or like not necessarily. But in general, we have our workflows are very dynamic, and like each models that gets released is a chance to improve our model workflow and make it even better. So I think it's a good thing. Like we wait for new models to be released and like to use them to try new ideas and see like what strength the new models have compared to the last ones and see like we when we're creating workflows we're trying to play to the model's strength, like trying to understand what the model is good at, what it's bad at, and how we can improve on the stuff that it's bad at and make it like better and find like more interesting stuff. So new models is a good thing, and I personally like it very much.
Great. My next question is, um, okay, this is a bit more controversial, I would say, but what do you say about if attackers can use this too, and the repo is public? What like does open source kind of help defenders more than it help attackers? Like what's the if you can make a case for it?
Yeah, I think I think it can. This case can be made for every security tool because attackers are always uh, have availability to reach every tool that like defenders can. But hopefully, like it, the way I think it can help is by reaching more defenders. Like it's like a game of numbers. Hopefully, I think that I like to believe at least that there are more defenders than there are attackers. So in the bigger numbers game, like where we provide this tool to more people who working to defend stuff, so it will result in like a positive impact on the community more than attackers receiving a hand, because like attackers are definitely, you can bet your ass that attackers are creating like internal tools all the time and like
Yeah.
very complex stuff. So I think like open sourcing tools and like creating a strong community around defensive security is a great way to fight back those state sponsored and like attackers and stuff like that, because yeah, they are very smart people.
Yeah. I have a note about a previous event we did about cold card. So Concite assumed AI found the cold card entropy bug before they did. Um, Given what you've built, um, is it plausible or a convenient story?
I have no idea, to be honest. I just don't know about this story enough to
Ah,
have
no problem.
a solid opinion. Sorry.
No worries. Um, okay, last few questions. Let's see. Okay, I think that's it with the good questions that I have. We have only a few more questions from the audience and one just Nice words. So let's go with the questions. How are skills executed when selected a few? Um, are they like a step of a workflow or something else?
The skills are basically provided to the agent, and the agent can access those skills and utilize those at the agent's discretion. So when you're using skills, I think it's like important to make sure the workflow steps that you are using are also aware that there are skills that they can use and can access. So yeah, that's basically the way that is implemented. And if you again, if you have like cool ideas, always feel free to write to us on the Discord and stuff like that. But yeah, currently the way that it works is the agent has access to the skills, and you just need to tell them in the workflow, and make sure to remember that.
Okay, awesome. So I think we're done with the questions. Just like as I promised, some nice words from the community.
Ooh.
And I think that's it for today. So I would like to thank you for this amazing lecture and answering all the questions, even my stupid questions or some of them. So thank you so much, Gabriel. It was a pleasure. And for everyone joining, I encourage you to join us, ask questions, contribute to the project. You can ask Gabriel questions in the Discord. Gabriel, if you can share this link with us, we'll share it in the group as well, and on our Telegram group. Feel free to tag us or Gabriel if you have anything else to add. And we encourage you to take part.
Yeah.
Thanks again, Gabriel.
Yeah, thank you so much for having me.
Awesome. We'll release the recording soon. It's gonna be on YouTube, on X, and on LinkedIn. If you have any questions for us or Gabriel, as I said, feel free to reach out. And just some finishing words. So we're the Web3 Devs Underground. Everything that we do is open source and free, and it's for the community, by builders, for builders. And as you can see, we have Gabriel here. It's the top builder, and also released amazing open source contributions. So if you're like Gabriel and want to come and speak at one of our next events, or you released something cool that you want to share with the community, please let us know. We would love to hear about it. You can share it in the group or with one of the managers. And yeah, until next time.
Yeah. Till
Bye,
next time.
Gabriel. Thank you so much. Bye,
Bye
everyone,
bye.
and thank you. We'll see you in 2 weeks at our next event.